Hi everyone, my name is Thomas Kim. Today is September 1st, 2022. This is my 48th episode for C++ 17 2023 CUDA cycle OpenCL DBB. In this episode, I will discuss rotational motion of a rigid body, moment of inertia denoted by I, purpose formula, also parametric representation. Recently, I purchased a few calculators. Please double-click this link. You can compare calculators from Texas Instruments, TI Nspire CX2 CAS. This model supports graphing capabilities. Also, it allows you to program using Python. This calculator is very good for learning simple programming using Python or BASIC. However, TI Nspire CX2 image. Please pay attention to the keyboard layout. The layout of the alphabets on this keyboard is very strange. It is not quadratic keyboard. The alphabets are laid out in alphabetical order A, B, C, D. Until you get accustomed to this keyboard, using this keyboard will be quite a headache. I would recommend you to purchase multiple calculators. For example, this is good for programming. This is good for simple calculation. I would recommend TI-84 plus CET this model because this model provides you lots of handy keys for special functions such as sine, cosine, tangent, inverse, square, log, natural log, exponential function, etc. This calculator is much simpler and easier to use for simple calculations. So I would recommend you to have two different calculators. This one is for simple calculation. This Nspire CX2 CAS. This is for programming. So try to have two calculators. But sadly, these calculators are pretty expensive in Korea. All of these calculators are over 200 US dollar, especially in Korean markets. Also, if you are a young man and planning to take examinations or tests, some calculator models are not allowed. For example, TI-89 Titanium is not allowed for ACT IB diploma program. In case of TI Nspire CX2 CAS, ACT is not allowed, so please consider this point. If you ever have to purchase just one, for example, I think this model is the choice because it is allowed for all tests listed here. As I said, these models are pretty expensive. If you want inexpensive or affordable but high quality calculator, I would recommend calculators listed here. For example, FX991EX. The price of this calculator is less than 20 US dollar. In Korea, you probably have to 20 to 30 US dollar to purchase this model. This model provides you lots of features as scientific calculator. For example, using this calculator, you can solve quadratic or cubic equations that has complex roots. I mean, you can solve equations of polynomials with real coefficient but has complex roots. It also supports single variable integration and differentiation, also four-dimensional matrix calculation too. I have used this calculator for last few days and I found this calculator is very handy. I rarely use calculators, but I decided to use these calculators not to be distracted. Please understand that graphing capability is very important. To solve some complex problem, you need to have solid understanding of the configuration of the problem. So graphing capability is a very important consideration. This model supports graphing. It costs about $100. If you are planning to take license examination in Korea, you have to double check if this model is allowed for your examination. Whatever model you use, if you need graphics capabilities, you have to understand parametric representation. Without understanding parametric representation, you cannot use graphic capabilities of your calculator 100%. Scientific and fraction fx 991ex. This is my choice of the calculator. It costs only $19. The reason I chose this calculator is that this calculator does not support graphics. Because this calculator does not support graphics, I can guess the shape of the function without drawing the graphics. Of course, I can make mistake, but my guess is correct most of the time. Also, it supports integration, differentiation, matrix, vector operation, even complex numbers. So it can solve most of the problem. Before you draw graphics on your computer or calculator, you need to improve your guessing capability. I mean, you have to be able to guess the shape of the function in advance before you actually draw on your calculator or computer. This book, Thomas's Calculus, 14th edition, teaches you all kind of function drawing techniques. I mean, if you study this book properly, you actually don't need to rely on calculators to draw graphics because this book teaches all the technology for drawing graphics. From chapter 15, section exercise 15.3, we will solve a few problems here. I will start Mathematica, then arrange side by side. This is exercise 15.3, area by double integrals. In exercises 1 to 12, sketch the region bounded by given lines and curve, then express region's area as an iterated double integral and evaluate the integral. If you want to calculate the area bounded by these conditions, you have to be able to guess correctly the shape of these functions. I will select example 3. Now, parabola x equals negative y squared. The line y equals x plus 2. Can you guess this graph? You should be able to guess this graph correctly in your mind. Drawing this graph using Mathematica or your calculator is not easy if you do not have parameterization or parametric representation. If we do not have experience in parametric representation, we cannot draw this graph even using Mathematica. Even if you use the best graphic calculator, If you cannot express your function properly, your graphics calculator is useless. Now plot x square minus 2x. We can draw this function. I have to change the style to input. I copy this, paste enter. I have drawn quadratic function, but we cannot draw x equals y square in this manner. We have to do parameterization, or we need parametric representation, parametric plot. This is the argument. Now we let y x changes from -5 to 5. Y changes from -5, 5. Shift enter. This is our plot. Now we have to solve this equation. I copy this function, paste. X is negative, y square. This is y. Now y changes from -5 to +5. So this is function x. This is function y. Y is function of y. This is parametric equation. Like this. This is negative. Now we need one more function. Here we need this graph. So we need another block. Copy this, paste. Y is still y. X is y minus 2 because can be represented x equals y minus 2. Okay, we can represent like this. Then this becomes x. Then we solve this graph. I will copy this, cut, and paste it here. Now we want to find the crossing point. Solve. I will copy this. This is comment. Now I put x square in this function like this. See once again, x is negative y square. Now I put like this. Then it should be equal we solve this equation. Now hit enter. Y is -2, +1. This is y-axis. -2, +1. So finally, we graph. Paste it here. -2.1, +1.1, or 2. Shift enter. We now have this beautiful graph. Without parameterization, we cannot even draw this function properly. Of course, in more advanced case, we can also do like this. T, 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 T. This is also possible. The same result. This represents function fx1, function fy1, function f2x, function f2y. Now let me read the problem once again. Sketch the region bounded by the given lines and the curves. We solved this part, then express the region's area as an iterated double integral and evaluate the integral. Now we integrate this problem. Here, integrate. This is double integral. We integrate outer integral with respect to y, because we will make strip parallel to x-axis. Then y changes from -2 up to 1. This is dy. We have to integrate inner integral. Integrate 1, then we integrate with respect to x. Then this is upper bound of x. This is lower bound of x. So lower bound of x is y minus 2 or minus 2 plus y. From this function, we represent x as a function of y, like this. Then upper bound, like this, y square. Now, this is this bracket. Hit enter. 4.5, because we put 0 here. We compute like this. 9/2. We split the view. If we scroll down page A66, 66, 15, 1. This is the answer. dx, dy. This represents dx. This represents dy. Y's upper bound is 1, 1. Lower bound is -2, -2. X's lower bound is -2 plus y, -2 plus y. Upper bound is negative y square. The answer is 9/2. 9/2. So, we solved chapter 15.4 this problem correctly like this. This is the graph in our book. This is our graph. Exactly matches